Good morning, students. This side Ankit Vyas. Today we are going to discuss about the various signaling during network transmissions. Students, it is very much clear that while we are transmitting our data within the network, so obviously there was a signal in between, right? So generally we do have analog signals and digital signals. So on the coming presentation, we are going to discuss about the various signals, how signals can be transmitted within the network, and what are the different varieties of the signals. So let us begin with the electric signals, the electrical signals or the current which we received on the power board. See, it represents the change in voltage over the time basically. The change occurs when the voltage begins at 0 and increases until it peaks. The signals then drops back down its lowest level, right? So generally, if we are talking about the electromagnetic signals, right? So computer network information flows from one system to another in the form of a signal via transmission medium. Guys, it is very much understandable, as we have already discussed on the last session, that if we are transmitting any data within the network, so we need three major things. One is the sender, another one is the receiver, and the mediator was the medium, communication medium, which we call it, right? So communication medium generally justify or it describe that yes, for transmitting data from sender to receiver, we need such a kind of signals so that we are able to transmit the resources in between. Let us have a look on the the graph. Basically the graph, we have sine waves, we have square waves. So we have two different varieties of graph available in the screen, right? So the signal can be analog or in the digital form if we are talking about the transmission of the data within the network. When a network card transmits the data across the network, so it sends out a signal that fluctuates in voltage. The pattern that the signal makes is called waveform, and we have two types of waveforms, are sense waves or are sine waves and square waves. So let's have a look of the graph. Let us have a look on the analog signals. The graph, we have sine waves, and we have, see here we have two things, students. One is the sine wave and another one is the time duration, which is being taken by that medium while the data is being transmitted from sender to receiver. If you're talking about the analog signal, an analog signal is a continuous waveform that changes smoothly over time. Analog signal can have infinite number of values and varies continuously with time, and it is usually represented by the sine wave. Let us continue. Each cycle consists of a single arc above the time axis followed by a single arc below the time axis. Example of analog signal is human voice. See, students, as we all are aware about that yes, there was a continuous flickering in our voice, right? And somehow it depends on the capacity, on the energy level, whatever we do have, right? So this whole overall things is depend, right? So it means you can say that yes, if you're talking about the signals which is being, which is being forwarded from our voice to the system or to somewhere else, right? So that signal can be known as an analog signals because there was a continuous change in between, right? If you're talking about the basic characteristics or the basic properties of the analog signals, right? So one of the important property among them is that is amplitude, right? See, an amplitude of a signal refers to the height of the signals. It is equal to the vertical distances from given point on the waveform to the horizontal axis. The maximum amplitude of sine wave is equal to the highest value it reaches on the vertical axis. Now let us see that how that amplitude is being measured. It is measured in volts, amperes or watts depending on the type of the signal. A volt is used for voltage, ampere for current and watts for power, right? And betterly you can have a look on the graph which is being shown in front of you. The next characteristic of the analog signal is period. See, generally period refers to the amount of time in which a signal completes one cycle. It is measured in seconds. Other units used to measure periods are milliseconds, microseconds, nanoseconds, and picoseconds, or vice versa, right? The third important characteristics of the analog signal is the frequency, right? Generally frequency means what? It refers to the number of wave pattern completed in a given period of time. To be it would be more precise is frequency refers to number of periods in 1 second or number of cycles per second, and generally it is measured in hertz. Other unit which is used to express frequency is kilohertz, megahertz, gigahertz, terahertz, etc. Frequency and period are increases of each other. It means it is parallelly depends with each other and it is being changed respectively as per the position, as per the situation of the graph. Periods is the inverse of frequency and frequency is the inverse of period, or vice versa we can say. The fourth characteristics which we do have for the analog signal is phase. What exactly the phase is? See, phase describes the position of the waveform relative to time zero. It describes the amount by which the waveform shifts forward or backward along the time axis. It indicates the status of first cycle. Phase is measured in degree radians. A phase shift of 360 degree, which indicates shift of a complete period. A phase shift of 180 degree indicates a shift of half period, and phase shift of 90 degree indicates a shift of quarter period, right? See, generally it represent phase was nothing but yes, phase, or we can say a kind of turn basically, or the alignment or the position, basically the position of the waveform relative to time zero. It means once it moves to the zero and post that it will carry forwarded from zero to the position whatever is being required. Now the very important thing is that why to use analog signals, or what are the advantages of the analog signals, right? So generally it is mostly used for the transmission of audio and video, right? It consumes less bandwidth than digital signals too. It means if you are talking about the bandwidth means if you are talking about the speed basically, right? So it need less bandwidth in comparison to the digital signals, right? And carry the same information. Analog systems are readily in place around the world. It means everyone is using the analog systems. Now, let us move on to the digital signal. A digital signal is a discrete form. It can have only a limited number of defined values such as 1 and 0. See, digital signals, or we call it as in computer signals, as it is very much clear that computers work on the binary form, right? It knows only bit, it knows only 1 or 0, right? So everything whatever we are transmitting with the help of the digital signals, that can be transmitted in the whether in the form of 1 or whether in the form of 0, right? The transmission of digital signals from one value to other value is instantaneous. Instantaneous means that is not being organized, right? Digital signals are represented by square wave, In digital signal, 1 is represented by having positive voltage and 0 is represented having no voltage or 0 voltage, right? All the signals generated by computers and other digital devices are treated as digital in nature. That's all. Let us have a look on the digital signal, that how digital signals can be represented if we are talking about the graph, right? So this is how the digital signals is being represented, right? We have 1, we have 0, 1, 0, 1, 0, 1, 0, right? Now, let us have a look on the basic characteristics of the digital signals, that what are the key characteristics which represent that yes, the particular signals are being treated as in digital signals. The first thing is bit interval, right? See, it is the time required to send one signal bit, right? That if we need to send a single bit of information, single bit means as it is 0, as it is 1, whatever we need to be transferred, right? So that particular interval, that particular duration basically, which is required to send one signal or one single bit, right? That is known as a bit interval. Next, it refers the number of bit intervals in 1 second. Therefore, bit rate is the number of bits sent in 1 second, right? So second we have bit rate. Bit rate means yes, how many number of bits we are sending within a second or within 1 second, that is represented as a bit rate. Bit rate is expressed in bits per second. Other units is used to express its rate are kb per second, mb per second and gb per second. Let us have a look on the bit rate and bit interval and the difference between both bit rate and bit interval in front of you. Next is why there is the requirement that I should use digital signals. Generally, it is best suited for the transmission of the digital data. It means if we have digital information or if we have computerized information, we are going to make the transmission of that particular information. So it is best feasible for that only. See, digital data can be easily compressed. It means if we are going to change or if we are going to customize its size, so that we can easily customize it with the help of the if that particular data is in digital form, right? And it can be encrypted. It means if you want to make your data more secure, so that can be also possible with the help of the digital signal if you're talking about, right? And equipment that uses digital signals is more common and less expensive. It provides better clarity because all signals must be either 1 or either 0 form. Let us have a difference between analog signals and digital signals, right, by using different factors, right, that is being displayed in front of you. Here we have taken different behaviors or different properties that we can say. We have been taken the nature of both signals. We have already discussed. We have already been taken the values which generally we are using in the both of the signals, whether in the analog signal, whether in the digital signals. Then we have discussed about the representation diagrams, that yes, how the graph looks like of analog signals and digital signals respectively. And at last we have already discussed about the various examples of both of the signals, that where generally we are using whether analog signal, whether digital signals it was. Now, what is the maximum data rate of a channel? Basically, maximum rate at which the data can be transmitted over a given communication path or a channel under given conditions is known as a channel capacity. Basically, the data rate of a channel is usually depends on following factors, right? See, first is the factor, next is the bandwidth of the channel, next is the level of the signals, right? Further, we have quality of the signals, that what was the quality of the signals which we are using, right? The quality of the channel is basically concerned with the level of noise present in the channel. There are two different theoretical formulas to calculate data rate of the channel, which is as follows, that we will discuss on the coming slide. Generally, we are using Nyquist theorem of noiseless channel to obtain the capacity basically, and we are also using xenon capacity formula for noisy channels, right? Let us have a look on Nyquist theorem. Basically, Nyquist derived the limit of bit rate for a perfectly noiseless channel. It states that if B is the bandwidth of the transmission channel which carries signals having L levels, then the maximum bit rate R is given by R is equal to 2B log base 2L. See, and the better explanation can be displayed for your convenience in the given example. Just have a look. As it is shown in the example, as per the formula, we have calculated that we have received 6000 bps speeds, right? So it is for noiseless channel is completely the theoretical and will not give accurate result because of the following reasons. The reason behind them is that we do not have, or no transmission channel is practically noiseless. If we increases the number of signal levels, the bit rate will not increase, because when the number of signal levels is increased, it creates a burden on the receiver and reduces the reliability of the system. So practically it is not possible to have a noiseless channel. Generally in the year 1994, Claude Shannon defined a formula called the Shannon capacity to determine the theoretical highest data rate of a noisy channel. Generally, Shannon says that the amount of thermal noise present is measured by the ratio of signal power to the noise power, called signal to noise ratio. The signal power is represented by send noise power by N, and the signal to noise ratio is S/N. Signal to noise ratio is expressed in decables. Shannon equations puts the limit of the number of levels L. The number of levels required for a bit rate 30,000 bps can be computed from Nyquist's formula as given below for your convenience. Let us have a difference between analog transmission and digital transmission. So here we have already mentioned various key factors, and we have already discussed the difference in between as per the factors which they are using. As we have nature of signal, we have values, we have cost, we have effect of noise, we have efficiency, we have security and privacy, we have integration, we have attenuation, we have maintenance cost, we have multiplexing techniques, we have error detection, and finally we have been discussed about the different examples on both transmissions in detail. Thank you so much for watching my presentation. I hope you all enjoy the session. If you have any query, you just feel free to contact me, or you feel free to message me, or you feel free to let me know about it. Again, once again, thanks all of you. Thank you so much for watching it. Please like, share, subscribe and comment. Thank you.